Hi there, welcome to this video. If you fly FPV quadcopters at all, you know that it's kind of a miracle that they actually can fly. And the way that miracle happens is through the flight controller, a little piece of hardware that we have inside the quadcopters that controls everything that's needed for this little device here to maintain nice, stable, controlled and controllable flight. All of that happens on the flight controller, and you can see on the desk here in front of me I've got 4 different flight controllers. In this video what I'd like to do is sort of walk you through the basics of flight controllers, what's on them, what they do for us, and basically how they work, and for you, if you're new to building quadcopters, how you would be able to understand them as you're going through a building process. To begin, let's just take a look at the basic styles that we can purchase here, or we can use in our quadcopters. Now, basically, there are 2 general types of flight controllers. Ones that can do completely autonomous flight, where you can just set it up and program it and it will fly by itself, and quadcopters that can't do that. The quadcopters that can't do that would be ones that we would typically use for freestyle and racing and things like that. The ones that can use autonomous flight are more for programmed missions and flying on its own and using waypoints and all of that. They have a little bit different components on the boards. So the boards that can use or that can do autonomous flight, they will have a barometer and some extra pads so you can connect a compass and GPS. Flight controllers that don't need to do autonomous flight won't have those parts, and they'll actually be a little bit cheaper. Regardless of which one you end up getting, every flight controller will always have 2 parts that are absolutely essential. The first one is going to be the main chip that runs the software that manages the flights. That's what would run Betaflight or iNav or whatever other software. And every one of these boards, every flight controller, also has what's called an IMU, an inertial measurement unit. Many people just say it's a gyro, but it's actually a gyroscope and accelerometer combined. Now, that gyroscope and accelerometer, they are what tells the computer in there exactly where the quad is in 3D space and how quickly it's moving away from a previous known location. How fast is it accelerating in a direction? And using that information, the chip that's in this quadcopter, in the flight controller, can then do all of the computations necessary to maintain the flight of the quadcopter by managing the rotational speed of the propellers. And that's all it's doing. With the inertial measurement unit, you'll see here on the boards, all of them have, where is this one here? Over here it is. All of them have an arrow. There's the one right over there. And that arrow marks the sort of the 0 point for the accelerometer and gyroscope. In order for it to work, it needs to have a starting point that it thinks is basically straight ahead. And that's what each of those arrows tells us. It tells us that the gyroscope accelerometer unit inside here understands that this is forward. And so when I would put it into my quadcopter, since this is the front of my quadcopter, I would make that arrow point towards the front. Now, there are ways to change that, and it's a little bit more difficult than I would like to talk about right now, but basically that arrow is important for this to know which way is going forward. And so when you're building, you need to follow that and make sure you keep track of where that arrow is. And so what we're going to do now is just switch over and take a look at the basic chip here very quickly. We won't talk about them very much, but today in 2024, there are 3 or maybe 4 chips that are still very, very commonly used in flight controllers. The most common ones are based on the ARM F4 series of chips and the ARM F7 series of chips. Now, if you take a look here, this particular chip is an ARM F405. This one over here is an ARM F411. And over here we have, and you can't see it because of the sticker, but it's an F722. And the one over here on this board is also an F411. Now, I'm just going to pull this little board aside here. For now, it doesn't really matter. And if we look at these ones, these three here, like I said, an F405, F411, and F722, those are the three most common flight controller chips that are used today in early 2024. And out of them, the only one that you might consider not getting would be the F411. It is the slowest chip out of the bunch, and it is starting to get to the point where it's reaching its end of life. It's still good for now, and it will still run many pieces, you can get several years out of it. It's the one chip that's used on almost every tiny whoop flight controller, and that's not going away anytime soon. So this is still a good chip to use, but it is sort of on its way out. The F405 chip is completely okay now. It can run any of the software out there, and that's also the same with the F7 chips. They have a slightly higher speed, and they are pretty much future-proof too, although the memory on the F722 may restrict it a little bit in the future. But for now, if you were to buy a flight controller with an F405 chip on it, or an F722, that would serve you for any purpose for the foreseeable future. And then I think that's really all we need to say about the chips for now. There's much more detail in other places if you need it. Now, what we're going to do next is take a look more at the actual layout and components on a flight controller. To begin, we've already talked about the main processor chip and the IMU. And so the next thing that you'll find on almost every flight control board is what's called the OSD chip. And that's for being able to display actual writing on the video that comes into our goggles. And that's, you can see, just a chip right here on each of these. Also on the boards, you will find voltage regulators. Different boards will have different numbers of voltage regulators. You will always have a 5 volt. And then on top of that, you will probably also have a 9 volt or a 12 volt regulator to provide 9 volts or 12 volts to different components. And you will also have a 3.3 volt regulator. We will also find on some flight controllers a barometer. And we mentioned this before. And if we take a look at these two boards and we flip them over, we can see that they both do have barometers. On here, it's this little tiny square piece of metal with the hole right inside it. And you can see the same thing on this other board over here. It's just right there. It's that tiny silver thing with the small hole in it. And that provides basically information on how high the quadcopter is from ground level. And without that, fully autonomous flight is very, very difficult to manage. So that's an important component on flight controllers that are designed for fully autonomous flight. And just as an example, if I were to bring this particular flight controller here into the mix for a moment, this particular flight controller here is not made for fully autonomous flight, and it doesn't have a barometer on it anywhere. Many of the flight controllers, especially the full-size ones, will either have a black box chip, or in some cases they will have a place for you to insert a micro SD card, and that's to be able to record flight data as you're flying, and then be able to use it to analyze what's going on with your quadcopter after a flight. And by using the data from the black box, you'll be able to sort of diagnose and figure out what's going on with your quadcopter. Now, for those like this particular one that don't have the place for an SD card, they will have just a small memory chip, maybe 8 megabytes or 16 megabytes, to hold the black box data. But that's really very small and only would maybe hold the data for 3 or 4 flights, depending on how long they are. Let's take a look at some of the other types of connectors we're going to have on these flight control boards. Now, you can see on this one and on here, we have a USB-C connector, which allows us to plug into our computer and power up the board to do the setup and other work that we need to do on the flight controller through our computer. You will also see that there are various what are called JST plugs, like these, and those are pre-soldered on there at the factory to allow you to have a specific place to plug something in without having to do the soldering. Now you can see here two that basically look the same, and those ones are for an ESC, like a 4-in-1 ESC connector. This particular board here does have another connector on it, and in this case with this board, that particular connector is intended to provide a direct plug for a DJI video system. So you will have different types of plugs on different boards that allow you just to plug in rather than having to solder. And each board will be slightly different. You'll just need to look up at the specs on the one that you particularly have. Let's get on to these golden pads that we see all over the place here. And for now, I'm just going to move this other flight controller out of the way, and we'll bring this guy a little bit more central. And then we'll start to talk about all of these different soldering pads that we see on the board. For the most part, they'll be on the top, but there will be some instances, not on this one for an example, but there will be some where the pins can also be on the bottom. Now, for this particular one here, it's got a very clear layout as to where the different pads are and their purposes. And so that's what we're going to kind of talk through now, is the types of pads that you're going to find on pretty much any flight controller, what they're for, and well, how you should use them. First of all, we'll talk about the ones that are related to electricity. Now, if you take a look around the board, you'll see various places where there are pads labeled G. And all of those pads that are labeled G are a common ground. They share the same ground across the whole board, and you can use one ground or a different ground. They're all the same, and they will provide grounding for your components. We have other pads like these that say 5V, and you'll see a few of them are in different places. Where's another 5E? There's another 5 volt there. And here we also have one that says 9 volts. Those pads are pads that will provide that much voltage. So a 9 volt pad provides 9 volts of electricity, the 5 volt, 5 volts. One thing to keep in mind is that here, I can't remember the total number here, but we've got maybe 1, 2, 3, maybe 4 pads that are labeled 5 volts. All of those pads combined have a maximum amp draw that they can provide. And that depends on the board that you have. And so you'll need to know the specs for that. But typically 5 volt rail will let you pull up to about 3 amps of current out of it. And a 9 volt rail would probably be very similar. Don't take that as exactly what your board will do. You need to always know the specs on yours to make sure that you're not overdrawing the current on them. Now, there are 2 more voltage pads that we should take a look at. One here is labeled 4V5, and over here we can see another 4V5, and then there's another one that's labeled 3V3. And what those are decimal voltages. So the 4V5 means 4.5 volts, and the 3V3 means 3.3 volts. And what's nice about those is that they receive power from the USB port. So when you plug your USB into the computer, the 4V5 pads and the 3V3 pads will be powered. And so that means any components that you've got connected to them, like your receiver or a GPS or whatever it might be, they will also be powered on, which will then let you use software to configure them and make sure everything is set up properly. The other pads, the 9 volt and the 5 volt pads, they're not powered directly from the USB. So there's another pad on here that we need to talk about, which I cannot see because, do we have one here? I'm not seeing one on here. So The one that I'm missing and not seeing on here is called VBAT, and that means the voltage from the battery. And that is basically a pad, and I don't see one on this particular here, but if you see one that's labeled VBAT, it is taking straight voltage from whatever battery you have connected. So if you've got a 3S battery connected, it will provide 3S voltage. If you've got a 6S battery connected, it will provide 6S voltage. So that's really important pad to remember. It is often used for powering devices that need lots of power, like your video transmitter, but you need to always be careful about that, because if you plug something in that needs lower voltage and you attach it to a VBAT pad, you will have problems. So those are the basic electrical pads. Beyond that, we've got a bunch of pads that are used for communication, and there are sort of two different groups of them. The most important group are what are called UARTs. That means Universal Asynchronous Receive and Transmit. And basically, they're just a simple way for the flight controller to communicate with another device. With UARTs, they will always come in a pair, T and R. T means transmit, and R means receive. And so the way they will always work is the T from this board, which is the mouth, will talk over to the ear or the receive on the other device. And the transmit on the device will go to the receive on this other board over here. And so the way they work is always in pairs, and you can see that they also have a number. 1 on this one over here. You can see over here there's another, that's T6 and R6. I'm seeing over here there's one that says R2 and T2. And so each of those numbers represents one UART. And depending on the board that you have and the chipset that you will have anywhere from 2 all the way up to maybe 6 UARTs that you could use. Not every board will have all of them available for you to use. Sometimes they're already used internally by how the board was designed, but they will be there for you to connect different peripherals to. UARTs, they're typically used for devices that need two-way communication, like our receivers, GPS units, things like that. Now, those were just communication pads, the UARTs, but we have others as well. If you take a look here, there is a VTX pad, and then over here there is a CAM pad, and those are for the video, the FPV system. The CAM pad over here is where the video comes in from the camera. It gets the information put onto it from the OSD chip so that we can see the writing that we want to see from the data on here, and then it gets sent out to the VTX through the VTX pin. And so those ones are for the FPV system. We can also see over here there is a buzz plus and a buzz minus. Those are for a lost model buzzer. And so if you want to put a beeper on your model so you can flick a switch if you've crashed your quadcopter someplace, and it will make a beeper go off so you can find it more easily. There are also pads here that say LED, and that lets you actually connect LED lights onto your quadcopter and put a little bit of bling on it. Now, this particular board also has places on each corner where you can connect LEDs. Not every board will have that, but this one does, just to make it more simple to put LEDs out on the arms of your quad, if that's what you want it to do. Okay. And if we keep looking here, we can see that here we have an SDA and an SCL pad. And that means serial data and serial clock. And those pads specifically are used for a compass. So if you have a flight controller that is designed for fully autonomous flight, as I said before, it will have this barometer here, and then it will have a place where you can also connect a GPS unit and compass unit through these SCL and SDA pads. So those are the basic pads that you will find on pretty much any board. The other thing that you will see on most boards are pins that are labeled either M with a number like M5, M6, M7, or sometimes they're labeled with an S. What you will find is that in this case, already in this pin setup here, we have the signals for 1, 2, 3, and 4. That would be signals for motor 1, motor 2, motor 3, and motor 4. And like I said, sometimes they're labeled as M, meaning motor, motor 1, motor 2, motor 3, or sometimes they're labeled as S, meaning signal, signal 1, signal 2, signal 3. And that's just the signal that goes out to the motor from the flight controller, telling it the information it needs to know in order to rotate properly. There really aren't too many other types of connections that you will find on your flight controller. There is something that I forgot to mention before, is right here, there is a button, and pretty much every flight controller will have that style of button, although sometimes it's a push down button, like this one right here, where it's actually a button to push, and that's called the boot button, and it lets you actually, when you plug in your computer, if you push that button down as you're plugging it in, it will put it into a boot mode that allows you to update firmware and do some things on the chip itself. So that is the basics of the flight controller. Now, I'd said earlier that I was moving this particular flight controller out of the way for a moment, and that's for a very specific reason, and that is, if you take a look at this flight controller here, we can see that it's got all kinds of writing on it, and it tells us what each pad is for. But on this flight controller, because of its size, there was no space for them to actually put any silkscreen writing. And so we have no information about what any of these pads are and what they're intended to be used for. What you'll end up doing is you will go to the website of the manufacturer of your particular board, whoever it might be, and you're just going to download the manual or the spec sheets for that particular flight controller. And so what we can do is simply compare the diagram, and you can see how it's got an arrow which lets us know which is the front and the top. And so we can see from this diagram that these pins here refer to those particular items there. And so in this particular case, we can see here that this one is labeled S1, S2, S3, S4. So signal 1, 2, 3, 4, that's for the motors. Then we have UART R6, current, ground, VBAT, the voltage from the battery straight, a 5-volt pin, a ground, and again, that camera pin where we can attach our camera. And so just by downloading this little spec sheet from the manufacturer of your particular board, you will be able to see what all of the pins are and how they can be used and what they should be used for. I hope that at a basic level, this gives you a bit more information and a slightly better understanding about flight controllers and what they're used for and the different parts on them. Thank you for watching. If you found this helpful and interesting, please take the time to subscribe, and I look forward to seeing you again in another video sometime soon. Until then, take care of yourself and have safe flying.